The whole time, no one's been able to hear me. And now no one can see me. How did I mute the audio on that? And we're good on the audio on that. So guess what we got to do? We got to start all over. I might even edit out that part of the stream. You know what I'm going to do? Editing streams takes so long. Watch this. We got to start all over, everybody. So we got to do it all again. You ready? We're gonna start from the beginning. We now have audio. And I know what it was. During the start of the stream, my audio was on the opening and I didn't see that and I turned it off and then I muted myself globally. That's what happens when you do things live. Is someone saying, there we go, general. Yep. Feel free to chat here. Ask any questions. There we go. I will work on them. I was muted to start the stream. Sorry about that. There we go. And so I'm going to go over the help sheet. If you didn't see, I was going over it, but you couldn't hear a single thing I said. So make sure you're clicking those. I might even remove that part of the stream, the intro part of the stream. But let's go ahead and take a look at the help documentation. Let's take a look. Here's the help documentation we were starting on, and let's talk about this getting help start thing right here. Now, if you need help, this is how to figure out how to use things inside of R. So you have here the question mark mean, and this is going to tell you what is something and how to use it. So let's go here to question mark and mean. Now you can hit F1 and any of these will pull up. So they're right behind my head right here. So you see, we're just pulling up different help documentation, but you can also go right here and click it and run it with Control or Command Enter. So I'm going to hit Control Enter because I'm on a PC. Let's put a note right here. Hit Control or Command Enter to run, to send code to the console. Now the console is where you run code. Up here in kind of the Word document space is where you write your code. So hit Control or Command Enter to send code to the console. And Control is on a PC and Command is on a Mac. So Control is on a PC and Command is on a Mac. If you notice, this is a comment because it's got the hashtag. That is not code, but this will bring up the documentation for how to use the mean. You could bring up the documentation for the standard deviation, just like that. And so these bring up documentation to help you understand how to use certain functions. And feel free, if you post a question in our class chats, I will make sure to go over them. Let's see next. What do we have next in the documentation? We have help search weighted mean. If you notice, it kind of shows you that this is a different color right here, and you'll see this as I copy paste it. So this is not correct right now. I'm going to remove this. I'm going to put actual quotes. You can do single or double quotes. Very important that you make sure you have the same type of quotes, single or double, and then I'm putting the word inside of it. Now, you'll notice it changed colors from being black to green. Like weighted mean is not black or green right here. I don't want to actually select anything, but weighted mean is an object right there. That's the object weighted and the object mean on line 3. That's not what we're trying to do. We want to search for the phrase weighted mean in the help documentation. So we're going to hit Control or Command Enter, and then we have the search in the documentation over here on everything that has weighted mean. So maybe you're trying to learn more about a specific topic. I can't speak today. So you can search the help documentation for that specific phrase, and you will find how to use the weighted mean or anything that you are searching. So what do we have next with helping learn stuff? We have how to use packages, and this one's really a lot. Because when you use packages, and once again, we're going to delete this because the copy paste does not copy in the right sort of stuff. And there we go. It's green, which means it's going to be a string. More on that in a moment. And a package is basically like, think when someone gives you a package, it's a bunch of stuff. So you've got inside of there maybe functions, you've got data sets, you've got all these different things. So it's all these different things that R can use. Functions, data frames, vectors, values, you name it. It's all these things that R is like, whoa, help documentations functions have. So you'll see we get help for the dplyr package. So it does have help documentation in it. And look at all these functions and everything we have, all these things that I wish I knew. I mean, I know some of them, but not all of them. And so we've got like bind rows, bind columns, all these great things, and it'll tell you how to use them if you click on any of them. We can count, we can tally objects. We won't use dplyr much in this class. We use a package called regclass a lot. And here's the help documentation on regclass. So you can see all the different data sets, all the different functions like build tree, build model. We have census data set. We got visualize model down here at the bottom. We got the wine data set, all of this great stuff right here. So if you wanted to like look through and see what's in here, like what is visualize model? It visualizes a model. It takes the object M, and then there's some additional optional arguments we could use. You don't need to read through all the help documentation, but it's kind of there if you need it. So this is how to use a package. And packages are things in R that have tons of information in them. They have data frames, they have vectors, they have values, they have help documentation. It's over that shoulder. So with this right here, we're almost done with this help section. We just have more about an object. So these are two ways to learn about an object right here. We have str, which stands for structure, and we have class, which basically is like, what is this? So let's kind of review this a little bit here, because let's go ahead and load up a data frame here. We have the iris data frame. This is inside of R at all times. It's a data frame of flowers, and you can take a look at it. It basically, you know, think about it. It kind of looks like an Excel spreadsheet. You know, there's the iris data frame. Kind of looks like an Excel spreadsheet. Just think about, here's your rows, here's your columns behind my head right there. So you can just think, you know, row 1, column 1, there's that data value. Row 1, column 5, is that 1, 2, 3, 4, 5? Yep, there we go. So it's just an Excel spreadsheet. But let's say you wanted to get a quicker look at it. You can run structure on it. Structure of iris is going to give you a quicker look at it. And here we are. So now you can see the first variable, the second variable, the third variable, the fourth variable, the fifth variable. And these are the first observations of 5.1, 3.5, 1.4, 0.2. It kind of goes down. And then we have the species. And the first species is Setosa. And that is that first row right behind here. Can you see it? It's right behind my head. There it is. Those are those first observations, because it's reporting each column, and it's telling us kind of the structure that this is a numeric variable. This is numeric factor, which, if you're wondering, this is basically quantitative. All these are quantitative, and then this is a categorical variable. Not an ordinal categorical variable, because it's just like, what kind of flower is this? But that's a categorical variable, and we should know instantaneously that categorical variables are seen as factors inside of R. So great job if you're following along right here. Structure lets you see the structure of something. I mainly use it for data frames to just kind of get a quick view of the data frame. So that is how you use structure to kind of see like, what's going on with my data frame? Oh, okay, here's the variables inside of it. And here's a quick look at the data inside of each of the variables. It kind of puts it, instead of it going this way, it changes it going long ways across. And then the other one was class. Now class is going to let us see how R views this object. The way R views an object is going to control how R manipulates that object. So what is iris? Iris should be a data frame. If I am correct, iris is a data frame. Good, I know one thing. So iris is a data frame. So when R runs certain functions on it, it will then manipulate it in the way a data frame is manipulated. So we need to know how R sees the object, so we can then figure out how to use that object. You can try a vector inside of here. We'll just do that for the time being. Oops, meant to do a $sign. And we can see how does it view supple length, and it views that as numeric. Hey, structure was telling us the same thing just a moment ago. Structure's like, this is a numeric object inside of the iris data frame. And you also see right here that the $sign connects data frames to variables. It's a very important note to take in this moment if you're following along, that if you have a data frame, you can, after typing your data frame, type a $sign, and it does really a great search. Like if I type length, it'll actually start filling out length. It searches through the string, or that's the characters, to find what matches it. And we might have our first question right here. Is there a difference between class and type of? Amazing question. There is like such a subtle difference. And if people put this in the comments below, it's so subtle. Type of basically does the same thing. Type of determines the R internal storage or storage method of an object. And so let's check right here. Let's do iris, and great questions. It sees it as a list, which is not saying the data frame. So it's seeing it differently right there. And so I'd really, there's so many questions and so many specifics that I love it. And so you get 100 points right there. Amazing question. I love that you're watching. Love that you're following along. Love that you're chatting, because we're doing chat a little bit differently these days. Mainly, you get the same result. I'm guessing that I will see, no, I think it's going to say double. I think it's going to say double. It's going to say double. I think type of might be more technical. We generally use class, but I think type of is a more technical view because that stands for double decimal precision, which numeric will be stored that way. Integer won't be stored that way. So I think type of is a more technical view. And let's look more into that to talk about the difference between type of and class, because there are some like big questions that even I've looked into, like what is the difference between null, and you see how that changes colors right there, NA, and is it NaN? There we go, not a number. So these all objects right here, the null object, the missingness, and the not a number object are all different things, and they all have very, 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 very subtle differences. So we will talk about more of those later on, but there's some very small things. I would say for the most part, you're pretty much fine to use class or type of. Both of them kind of tell you how R is seeing that object and will manipulate that object. Like how is that being stored? I would say at the moment, type of is a little more technical because that's talking to more like the computing side of it with double decimal precision. And then class is more how I think of objects. If you notice how class is giving us numeric and type of is giving us double decimal precision, which is more of a computer technical side, which is good. So if you don't know what double decimal precision is, don't worry. It's how things are stored with, what is it, 32-bit memory? Is it? So, because yeah, it's probably 32-bit operating. So if someone in the chat or elsewise knows, I think it's stored at 32-bit memory. I'm not a computer science major. Sorry. But no, it's so great when people ask the questions because then I learn more about like what are the subtle differences. So we see right here, this is going to basically tell us how to use things and tell us what things are. We've already done a little bit with libraries right now. So with using libraries, first thing we need to do is we need to get the library. Now, I'm not going to install dplyr. I wouldn't suggest installing that. And do remember, there is a problem with this copy paste because that's not a string. Strings turn green, at least with my color displays. I'm going to install reg class. So if you're in 320, you need to install reg class. Have reg class installed, and 474 uses it also. So with this right here, let's take a look. If I were to run this, we would run this, and it probably would need to restart my R, so we're just going to not run it. We hit Control or Command Enter. I'm going to comment it out for the time being. Boom. And let's do this right here. Let's do working with packages in R, so we can maybe post this later. We could post this in our class session. So there's working with packages in R. And let's take a look again. That will install the package. And then once you've installed the package, you then, every time you load up R, you need to run the package. And please remember, there is autocomplete. Autocomplete's your best friend. Autocomplete, you're always there for us, autocomplete, until you like make a mistake. Autocomplete doesn't help you out sometimes. We're gonna hit enter on this, and we're gonna hit Control Enter, and that'll load reg class. Now, I've already loaded up reg class on my computer, but let's say there was a package I hadn't loaded, like ggplot, which I have. It'll do a bunch of loading in the background. Or plotly. If you notice, these are auto-completing. These are packages I've installed. If you're trying to run these, it's because you haven't installed them if they're not showing up. So if you wanted to load something like plotly, or shiny's probably loaded up right now. There's shiny right there, and you notice how the color's different. It has the package next to it. Just like, we saw another one. Oh, there we go. Stats. Let's load up stats. We're in stats. Let's load stats. So there's where all your packages are. Now, an additional thing is, a lot of times I'll look and see what packages I have currently loaded. Please make sure you commonly stay in the global environment so you can see what's loaded into R. But with that said, you can look at plotly and you can see the different functions. You're now looking inside the plotly package, but you can go back to the global environment by clicking around here. So if I wanted to look inside of reg class, I could look at all the functions. I could also look at the help documentation we saw earlier. So if you're confused on how to use any of those, remember, you can then look at the help documentation for it over here. You can also look at all the functions here. So there's kind of two ways to get help with the packages right there. So there's how to use packages and how to load them. You only need to load a package, or excuse me, you only need to install a package one time. Install once, unless updates, ... unless updates. I see there's another question. Thank you so much for the questions. I really mean that. I'm gonna look at it in 2 seconds here. And every time you restart R. So it's like when you restart your computer, you might have to load up the video games again. Is there a difference? Wait, it's in another section. Or maybe I missed it. Let's see. Okay, cool. Might be cool. And let's take a look right here. Every time you restart R. Now the next thing we need to do, let's take a look at the next thing right here. Dply R. Yes, I actually didn't know this till recently. I mean, I just don't use it. So if you look at this code right here, this is how to access a function inside of a package. So you can kind of go inside of packages right here, like reg class. So we're going to go to reg class, and then this can utilize stuff inside of reg class. So maybe you don't want to load in a package, you just want to access something inside of it. And you go here, and you can access the things inside of it. Can we access survey? I guess it accesses the functions. I don't use this a ton, so there's a lot of optional things here, but this can access the functions inside of it. So if you wanted to do something like visualize model, you could do it right here, and you're basically calling the package and going to a function inside of it. So this is how to call the package to go to a function inside of it. So you have to do : : I don't use this one that much. I prefer to just load up reg class, and you've loaded it up here, and then I prefer to do visualize model, and these two codes are pretty much identical now because this could be used if you haven't loaded reg class to go to reg class and load the function, and then the top one right there would be after you've loaded reg class. So this one requires, let's put that next to it, requires a library to be loaded, allows you to access function without loading library. So just a small subtle difference right here, and you might say, well, why would I possibly do that? The only instance I can think of to not load the library is maybe you're running code that uses a big library and you're like, okay, I only need this one function. It's probably smarter coding. Like if I were to code things that took longer or computers were slower, they're super fast these days, it might be smarter to only load in like the function you need to just access that. So probably less resource intensive, but yeah, maybe I should start doing that. Maybe I should start being like, oh, I should just call the function I need. We have data iris. This is going to load a data frame that is inside of R's memory already. So these are data frames inside of data right here that already exist inside of R. These are not Excel spreadsheets. These are not tables. These are not CSV files. Those have read CSV, read table. More on that when we get to that section in this help documentation. But this will load in a data set that R kind of has. It's like preloaded video games I always compare it to. They exist on your computer at all times, as long as you have like the packages loaded, and you notice, boom, and that promise right up there, that took me like a year to find out what promise meant. It means R promises it's there. Why do they say that? Yeah, that's what it means. It means R promises it's there. It's like, we promise it's there. And so a lot of times what I'll do is I'll load another data set, and I've seen this. So I've got survey 9 right here. These are inside of the reg class package. If you can see right here, these say reg class next to them. It's easier to see when I don't hover over it, but they say reg class. And for some reason, when I load this, it'll stop saying promise, or it'll still say promise. It promises it's there. Well, let's leave it up there. R promises it's there. Let's check R. Yeah, it's right. But wouldn't. I look down for 2 seconds and it stops. Oh, I think it's when I ran that. That's what you have to do to say it, make it not say promise. It promises it's there. It's there. You notice I loaded in 2 data sets. You can see a little bit about these data sets, that they have 150 observations for iris and 5 variables. That's what you're viewing on the screen right now. 150 observations, 1, 2, 3, 4, 5 variables. This is not a variable. The numbers I'm hovering over right now are not variables. That is just the position in the data frame. So you can see the same thing if we were to go to survey 10, and you can also click this to open it and to view kind of the vectors inside the data frame. And you can click right here to see it in like an Excel spreadsheet format up top. So a lot of people like to just kind of take a scan of it and see what's going on, understand your data, know your data. And that's the data frames right there. We've now loaded in the data frame, and it's in the brain of R. This is the brain of R right here. This is what R knows. We'll be removing its memory in a moment. I think that's got it for this section right here. We have now loaded in the data. So a very important thing is we have our working directory. So when it comes to our working directory, we'll just highlight this here to start. And I think I'll worry about drawings later. When it comes to the working directory, this is where you're currently working with your files inside of R. Now, this is where I see a lot of mistakes, is because people maybe make multiple directories for assignment 1, for assignment 2, for assignment 3, and then they get lost because they have this here and this here. You need to, when you bake a cake, have your instructions and also your ingredients in the same spots. Like you need to have your RMD file, your instructions, and you need to have your ingredients, your data sets, your files in the same spot. So when you run this function right here, the get working directory, it'll just tell you your working directory. So let's go here and working directory information. So if you just do get working directory, oh, can't type, get working directory, that'll just get your working directory for you. Stat.1 downloads is where I'm currently working in. I just work out of that area because if I were to change it every class, it would get confusing. Now, you're probably just in 320 or 474. Feel free to make a 320 folder and then just keep everything there. Maybe you might put old files in a different spot, but keep organized, because if you don't have everything in the right spot, it just doesn't work. And I know it's probably the one quirk of me is I just put everything to downloads. That way, especially when students send me files, they're like, hey, Brian, this won't run. I don't have to worry about moving it. I just download it. It goes straight to downloads and I run it. Not the best organization, but really good for speed and for replying to emails. That's my goal. And so set working directory right here. This will just change your working directory. This is how you access certain paths on your C drive. So you can see my current path right now is right here, users, stat.1 downloads, and then you could change right here to the different files you want. And you can use the format probably that I have right here. Like if I wanted to change it to just stat.1, I could go set working directory, and this needs to be in quotes. Yep, it can be in single or double quotes. So we can go to set working directory, and we should be able to go to this, and that's set the working directory. Let's get the working directory again and do this. Now you don't have to do it that way. You can go to tools, and you can go to, where is it? Have I lost it? Session. So when you do things live, it's like, wait, where is that? You can choose your working directory here. This is very important. I have a whole video on setting your working directory, because usually you just want to set it as a default. So you can go here to choose working directory and set it this way. Probably one of the easiest ways to do it. And I know why I said tools, because you can go to global options and set your default working directory. So under global options, there's the option to set your default working directory. Let's just show where that's at right here. So here's my default working directory. That's why it booted to downloads. You can set that right there, or you can change it by just going to here to set working directory. And this is where your files, your information needs to be to make sure you're working in the same spot. Your working directory can be seen by going here to files, and that will go to your working directory, and you can currently see where you're at. With all of that, we're on to the next thing right here. We're making excellent time. We're going to move the screen over and talk about vectors. So what are vectors? A vector is basically information. You'll see right here, we have the C function. When you see these parentheses around something, it means it's a function, or you're doing mathematics. I should mention that caveat. So we have C parentheses, means it's a function, 2, 4, 6. So right here, whoops, there's my audio devices. Let's go right here. And let's go to working with vectors. I think RMDs now have a spell check. Should have used an RMD. This is an R script I'm currently in. 2, 4, 6. Now, what's going on with this right here? So this 2, 4, 6, this 2 right here is the first argument, the 4 is the second argument, and the 6 is the third argument, and they're going to be glued together in a vector. So I can run this right here, and there's the numbers. You can do mathematics with vectors. You could go plus 1, 3, 5, and there you go. You could go times 5. That's times 10, because then it'll be pretty obvious. So you can do vector mathematics, all these different things. R is great for using it as a calculator, but as you can see, it's just taking 2 multiplying it by 10, 4 multiplying it by 10, 6 multiplying it by 10. And so if you think about this, you just have a vector of numbers right here, and you can return it. So all this C thing does is turn things into a vector. And they don't mention this in the documentation, but you can make vectors of different things. You can make a vector of your name. Adam right there, so that's a vector of 2 names. Now I shouldn't be able to multiply this because it's going to say attempt to something. Non-argument, if you can't see, there's the arrow behind me. It doesn't like that because it's not numbers. If you notice, this is green and this is blue, this is strings, this is numeric. So it doesn't like that, we can't do that. But I just wanted to point out that you don't have to have quantitative vectors. You don't have to have numeric vectors. You can have vectors that are characters. You can also have vectors that are factors. More on this later, but I can make this into a factor, and now that's a vector that is a factor. So how did we turn it into a vector? We concatenated it together, and then we can do other things to it. So if you notice, there's a factor function around it. Here's the original function that turns it into a vector, and then the factor function is around that. So that is inside of it. If it seems a little bit complicated right now, watch this. We're just going to store that to x, and then we could just do a factor of x. More on that in a moment. I don't want to go too advanced. I want to go step by step right here. But one key thing you should note is that factors are just things kind of glued together. Factors are things glued together. We've got right here a quick way to make a vector of 2 through 6. One of my favorite ways to make quick vectors. You can just make a vector of 1 through 1,000. Why not? There's a vector of 1 through 1,000. You can make a vector of 2 through 100. There's a vector of 2 through 100. So right here, this colon just goes blank through blank if you connect two objects together. An important thing to note is it only goes by 1. We'll have a way of changing that in a moment, but this goes 2 through 100 and just makes a really quick way of making just sequences of numbers. So let's put a note like that. Quickest way to make sequences that go up by 1. That's a super quick way to make sequences that go up by 1. And right here, we have a sequence from 2 to 3 by 0.5. There we go. So let's copy paste this. And they should really mention what's going on right there. They show you it, but they don't tell you what it's doing. So the first argument in sequence is from to by. They don't label these, which a lot of times we suggest you label your code because it helps so people can read what's going on right here. So these both will print the same thing. I've just kind of added the notation next to it that this is from to 3 by 0.5. I know I'm having a problem. From to 3. It sounds weird. What if we go from 0 to 3 by 0.5? There you go. So you can see right here, this is how to use the sequence, especially if you want to make a sequence that doesn't just go up by 1 each time. Great stuff right here. Just easily make very, very quick sequences. And tip for people doing some assignments right here, if you're watching this video, if you want like the third element, you can get the third element of that sequence by doing square brackets. More on positions later. But that is how you make a sequence right there. And the default ordering is from to by, and it's probably best to just label them, especially at the start, so both you can understand what the code's doing and maybe someone else who reads it. I should label my code more often, and always ask me to if I forget to. Rep is going to repeat things. That's what rep stands for. So we've got that we're going to repeat something. Let's go here to rep, and this is going to rep the sequence 1, 2, 3 times. So we can see right here, I missed the parentheses. It's going to go 1, 2, 1, 2, 1, 2. And I like to do test questions like this that say, well, what's this code going to do? You could say, you know, rep, well, that'll rep 1, 2 in colons. See, that changes it. It's a string now. Or we could say Brian. So this is repping the character string. Please note, you might wonder, why didn't it do 1, 2, 1, 2 that time? It's because this time it was a string because it was in quotes. That no longer treats it like numeric. It changed it to the word 1:2, not the sequence 1:2 as we saw before. That's a little complicated. If you're following along, great job. The big thing to understand right here is with rep though. What does rep do? It has 2 arguments. Each argument is separated by a comma right here. So the first thing is, what do you want to repeat? How many times do you want to repeat it? Arguments are separated by commas. So there's 3 arguments up here. First argument, second argument, third argument. 3 arguments there. So that is how we use the rep. And there was one more example we can take a look at. We've got here rep. Oh wow. I didn't even know that. I didn't know. I saw rep when I was looking this over. And I was like, I know how to use rep. But I didn't know it had a different argument we could use. So this is going to rep. Instead of doing the sequence in like order, it's going to rep 1 3 times and then rep 2 3 times. Very interesting. Didn't know it would do that. Because if we do 1:2 with times, it does 1 2 1 2 1 2. And so let's just bring this back here. And so I didn't know. There's 1 2 1 2 1 2 because it's going to rep that sequence 3 times. But with each, it's going to do each one 3 times before moving to the next one. I haven't used that before, but that could be useful. I'm sure if I knew of it in the past, I might have a way of using that. So you notice here, this is a different argument and it does a different thing. It reps each one that many times before going to the next one. And what do we mean by argument? Arguments are basically instructions inside of functions. One of my basic examples to understand that is make dinner. And we put inside of here Let's put pizza, the object pizza, not the word pizza. So what does this function do? It makes dinner and it makes pizza, but you could change this. You could change this to chicken. There we go. So this function makes dinner, and it takes the argument, what dinner do we want to make? You could put an additional. This is just kind of a joke function right here. We're making 4 servings. You could put salad, and you could put 2 servings. So arguments are instructions. Make dinner is the object we're going to make for dinner, and then we're going to make this many servings of it. So think about, you're just telling it what to do. Like up here, rep this and rep each thing 3 times before moving to the next. That's just instructions for what it's doing. And now we are down to vector functions. Cool. So now we have some vectors. We actually need to store them. So they did this a lot of order because I think later on they show you how to store stuff. So I'm going to show you how to store something here right now. Since we have these objects inside of R, we're simply going to take and we're going to store one of them. So let's go here to X save into and save that vector. Now, if you look over here in my global environment, you will see that I have stored the object X, which was 11222. I think I said of 2s. So this is the object, the vector X, and all it does is take this and store it into there. Just kind of look how the arrow goes into that. That's going to store this repeated vector of 111222 into the object X. So what can we do with this? Let's take a look at some options. We have the option right here to sort it. So it's going to sort the vector for us. This is not that interesting of a vector. That's not that interesting. Let's do a more interesting vector right here. And let's do this. Let's do working with vectors. So this one wasn't called working with vectors. It's called vector functions. Okay, so let's make a more interesting vector to sort. We know how to make vectors now. So we're going to store one as X. We're going to delete this old one. I am triple clicking the line to delete it and then just deleting if you're wondering. So you triple click and you can select a whole line. I'm going to concatenate a vector together of the following numbers. So here's our vector, very short vector of just numbers, and we overwrite X in the global environment. So when I sort X right here, what do we get? We should get 1, 3, 4, 9, 10. Boom. There we go. It has now sorted that from smallest to least. There are additional functions right here. I believe it's decreasing or descending. Decreasing, yep. So you can do decreasing equals true, and you can do decreasing. So these are kind of small things right here that you don't have to do this by default. It'll do smallest to largest, but there are additional arguments if you want to go from largest to smallest. So look over here at the screen where I've sorted it one time from smallest to largest, and you could also technically do this, and it would still store it the same way. If you're wondering why we didn't need to enter this in, it's because this is set to false by default. So you don't need to enter that in. By default, that is false. So arguments actually have a thing called defaults, meaning you don't have to enter in things for them. It'll automatically assume you want that to be a certain level. It'll either be false or true by default if it has a default. Going on right here to the next one, we have table. So we can make a table of this vector right here. And it's not going to be that interesting. It's going to give us the count of the objects. So there's the table. We could make a more interesting vector right here. Let's go and make a vector of some names right here. Let's go Brian with a B-R-I-N, and then Adam. And so now when we make a table, this vector right here, it gives us the count of the objects. It'll do it for quantitative, but we usually don't make tables of quantitative variables. There's instances where we do, but we have on the screen right now a table for a quantitative vector right here, and we have a table for a categorical, i.e. factor vector or character vector, and we could technically turn it into a factor. It'll still act on it the same way right here. It is a character, and now it's a factor. And I just wrapped it inside of a factor right there to turn it into a factor vector, and it'll still produce the same results because it acts the same way on it. So we can get a count of the amount of observations with a table function right there. Reverse, that's rev right there for reverse. That's Brian, Brian, Adam. And now it's Adam, Brian, Brian. It should be. There we go. Adam, Brian, Brian. So we've reversed it. If we had done it on the first one, it would have been 3, 9, 4, 1, 10. And we can see this right here. If we do the reverse of it, it should be 3, 9, 4, 1, 10. And we can reverse it. 3, 9, 4, 1, 10. It just reverses the vector around for you. Next, great stuff. We've got unique. Ooh. So unique right here is going to give us the unique values. So this is where you got to pause and think through it. I'm going to overwrite. We'll start the first example. So unique is only going to report the unique values for this. And this is a very good function I use quite often. So it's going to actually report 101493, all the unique values. But when you want to see a difference, check this out. Think about what this will report. This is going to report all the unique values of X. So there's Brian, Adam. So we're going to report all the unique values. It'll report Brian, Adam, but not Brian, just Brian, Adam. So it reports only the unique values. So if you have a larger data frame like we do with survey 10, we could do something like unique, and we could do survey 10, and we could do people's heights, and these are all the unique values of people's heights. So what you see behind you, and you could even go further, and you could sort them. And if you wanted, you could just reverse the vector to do largest to smallest. You could change the argument. There's lots of ways to do it. If you see, we kind of used all the different things we were doing right here as an example, and I found all the unique values of people's heights. I sorted them, and then I reversed them. I could have just done decreasing equals true, but I was kind of showing the different types of functions we just learned and putting them all together with a vector inside of a data frame. So this right here, just to review, is the vector inside the data frame. We are then taking all the unique values of that vector. We are sorting all the unique values of that vector, and then we reverse the vector that we got. So that's a good quick review. I know that was a big example. We would like to go from small to big, some simple stuff, and then we kind of end with a little bit of a bigger idea on it to see what we got going on. Next, selecting vector elements. Yes, this is the good stuff right here. So let's go and select some vector elements. You have to know this stuff. Selecting, not that you don't need to know the other stuff. Selecting vector elements. So the biggest thing right here, I have to do like this. Don't do that. But that right there is one of the keys to positions and elements. You'll see that when we look at data frame positions, when you'll see that when we look at lists, but you have to know the square brackets. It's these square brackets like this. I wish I could put it in chat right now, but square brackets. They'll be right next to P of the enter key. It's the square brackets. So make sure you are zoom in, look at the screen really closely. You need these square brackets. So let's go ahead and see what we're talking about right here with our first examples. We have the element position in a vector. So if I go to my vector X right now, which is currently Adam, or it's currently Brian, Adam, and I go to position 3, you should say that should report to us Adam. If you notice, it does tell me the levels of it, but it's telling me the levels are Adam, Brian. Now that's not what it's reporting. It's reporting that position 3 is Adam. You might say, why does it have 1 right here? That's because it's only reporting one thing. You'll notice it with the longer vectors. This is the first thing of what was reported. This is the 12th thing, the 23rd. You notice how it has square brackets? Because it's positions. And we might have another question. Let's take a look. So on assignment 1 for 320, it asks in question 3 for the type of gender code, but later we named gender code to just gender. So gender code is just null. You're right. Use the one that does exist. So you can probably hear me right now. Use the one that does exist. So you're meant to use the one that does exist. We should make a change to that. And then I'll make sure, tell me if the graders take off points for doing type or class. Both are correct. It's just how does R see this object? I would use class and use the one that does exist. It shouldn't be null. Null means that there is nothing. Just a real brief thing on null. NA is missingness, that there exists a basket where nothing exists in the basket, and we don't really care about the basket. But then null means there is nothing. There's no even memory allocation to it. So does that make sense right there? Feel free to ask. Great questions right there. Hopefully you're watching the video, and because I can reply to that more later in the chat. But that is the video answer right there on how to do that. Awesome. Good deal. I've got that up in the background. So you can always interact with me live. And I was like, today I'm going to go through this whole sheet. No, but keep asking questions because that's what this is for. And I'm glad to, my whole goal is to help people out with this. Everything but the certain elements. So we're just going to subtract off an element right here. So if you notice, if we take vector X and we go to position, everything but 3. So try to read it as a sentence. This is everything but the third element. And there we go right there. It's Brian, Adam, because the original vector is Brian, Adam, just so you can see. Let's see the original vector again. It's Brian, Adam. So X minus position 3 is Brian, no Adam. Once again, this is the reported vector. This is just the levels of the reported vector. Next, we have to go through a certain amount of elements. You remember earlier we did where we went and chose a number sequence going from like, here we go, 2 to 100. Well, we can do the same thing with positions. We can go inside of X with square brackets and go from position 2 to 3. Now remember, it's Brian, Brian, Adam. You should know what it is. Since it's Brian, Brian, Adam, it should be Brian, Adam. And this right here is the positions 2 and 3 of the vector. It's just reporting Brian, Adam, because that's the second and third position. If I went positions 1 through 2, it's going to do Brian, Brian. Now, what's really interesting, if you go through position 5, I think it will be Brian, Brian, Adam, NA, NA. Yes, we did it. And we just mentioned this a moment ago, that NA means missingness. It's saying to you that there does not exist things in these positions right here. So I went through positions that do not exist in this vector, and those NAs right here means there's nothing in those positions. Those positions do not exist. So NA is a special character, and it's telling me those positions do not exist. You generally wouldn't do this, but it's just reporting to you that there does not exist things in position 4 and 5 of that vector right there. So that is how we go to a vector of positions inside of a vector. Vector of positions inside of a vector. Lots going on right there. Now we have everything but certain positions. So check this out. Let's do the same thing, but let's go right here and do 1 through 2, but everything but 1 through 2. Remember, it's Brian, Brian, Adam. So what will we have? We will have just Adam. And I made a mistake. I think we need to do this. Don't tell me they have a mistake in theirs. Did they make a mistake in theirs? Oh, I made a mistake. If we had Streamlabs going, that'd be Brian's first mistake right there. I looked down and I was like, shouldn't that be in? Shouldn't that be in? Because you can do -1 like we did, but you're telling it to subtract out this vector. And we all make mistakes when we code. That's the way it goes. Nice job. One last question. Can you go over what kind of things we should look for when looking for data integrity issues? Yes. When looking for data integrity issues, try to see if a value is too large or too small or doesn't make sense. Like if someone said how tall they are and they said 180, and you're like 180 inches, 180 centimeters, at least with the way we report things with inches, 180 doesn't make sense. If someone said how much they weigh and they said 5, you'd be like, yeah, people can't weigh 5 pounds. If someone said, how many days do you go to school a week? And you said 9, you'd be like, you have 9 classes, you have 9 hours. It doesn't make sense when you say something that is outside the bounds or is not reasonable. I think in one of the classes we talked about, what if someone reported 2.5 for how many children they have? You'd be like, how do you have 2.5 children? So understanding if data has issues with its integrity requires us to know kind of a little bit about the data. So think about, does it make sense? Look at the values in the data and ask, does it make sense? So if these are names of kids in a classroom, you might say, yeah, it makes sense for Brian, Brian, Adam. But if this is like food we're going to eat, you'd be like, Brian, Brian, Adam, that doesn't make sense. That'd be a data integrity issue if this is the way it was recorded. So always, you have to ask those questions like, does it make sense? Hopefully that helps right there. But data integrity is literally the idea of, does it make sense? This is how to get just specific ones. We're going to take a vector and choose only the elements 1 and 5 inside the vector. And we're kind of doing our own examples, and feel free to do clarifying questions. I hope that helped out with that. But we're going to take just right here this. And what's really interesting is they don't show something here. Remember, it's Brian, Brian, Adam. So Brian, Brian, Adam. So we're taking Brian, Adam right there. They don't show that you could go, and I believe go right here, and we should just get Brian, because that's element number 2. So lots of ways to use this. Here, let's do this, and take this, and go right here. And let's see follow-up. I think I got to wait. Might have another question in another spot. I don't know who can help me, but for the files on R1 Basics, can't be able on PC, I don't know how. Email me. I see if you're watching this now in the video, email me. Let me message them real quick on here. Email me and I will get it fixed. I am currently live on YouTube. There we go. Good stuff. Let me hop back to Stat1 Discord. And Tia might handle that too. We'll see. Okay, I think we got through the vector stuff, right? See how far we can get. We got another hour and 10 minutes. Good stuff. Ask the questions. Ooh, this is good stuff right here. So we've got logical checks now. This is kind of getting a little more complex with the logical checks. We've got equals equals, which is logical equals. I'm going to have to make a numeric vector again. We're just going to go grab our classic numeric vector right here. If you're a little confused, we could call this vector y. So I'm calling it y now to just give it a different name, and it's a numeric vector. And what I'm going to do is I'm going to go inside of the vector, and I'm only going to return things that are equal to 10. And that literally returns 10. So we only get the things inside of the vector that are equal to 10. Now, I wish they told you more about logical checks, because let's talk about this right here. This is equals equals, which is logical equals. Logical equals will return a logical vector. So let's look at a logical vector. The logical vector right here is telling us whether things are equal to 10. And I say equals equals because there's two equals. So when I run it, I say equals equals. Like, is this equals equals to this? Logical equals. And so it returns trues and falses. Take a look at the vector over here, 10, 1, 4, 9, 3, and look where the true is. The true is right here on 10. So interestingly enough, when you put in this true false vector into here, because that's literally what's inside of here. Like, it's just, let's just call this logical. Let's just score this as the logical. And you're just putting this logical vector inside of here, and it only returns the true elements. So it's like only return the things that are true right there, and it's returning 10. Well, we could do different logical checks, which I think they're going to do next, and we could do one greater than 5. So now let's say we did a logical check here, and we only want the elements that are greater than 5, and we should see true, false, false, true, false, true. Oh, wait a minute. Greater than 10. Haha, second error. Greater than 5, true, false, false, true, false, and then we can return those elements, and the elements are 10 and 9, so we can only return those elements. We use that for people's heights and stuff like that, but that will return only the elements that meet this condition. And you don't have to code it this way. You could just code it as one thing, because all this code right here is going to do the same thing. It just might make more sense for you to do it in 2 steps. To be like, let me store the logical check. Okay, here's the things that meet the condition right there. You can see the first and the fourth element, and you can see the vector over there behind my head that way. The first and the fourth element, which are 1 and 9, meet the condition of y greater than 5. And then we would report those elements here. And that just gives you those elements in their own unique vector. And I think, yep. Awesome. I will email you back, and we will get it worked out. We'll get it working. Great job, everybody. I love how interactive everything is. And so great job. Keep it up. We will get everything worked out. So there is how to return certain elements that meet conditions. And then we got a big thing right here. We got x contained in this vector. So the contained in is probably one of the hardest ones, I think, for people to wrap their minds around. And I say that because even I had a little bit of a hard time when I was first learning it, how to do the contained in idea. So when we do contained in, it's read percent in percent. That's the way it's coded. And if you notice, it changed colors right there to a gray color as I did it. Just watch again as I type percent I in and then percent, and it changes colors, making it a specific type of code. And we're going to ask, is 4 contained in the vector 1, 2, 3? So I just want you to think about this. If I asked you, if I said, is 4 contained in 1, 2, 3? And if you were a computer, you would say false. So it's just checking to see if that is contained on the other side. How about, is 1 or 4, and this is 1 contained in, is 4 contained in? It's not 1 or 4 technically. I misspoke for a moment. It's, is 1 contained in that vector? Is 4 contained in that vector? I'm asking you 2 questions. So you would say true and then false. That's how the percent I in percent works. And so they're using percent I in percent here to return certain elements. They're asking, is x contained over here? And that will do a logical check. It'll return trues and falses, and then the things that are true will be returned. So we can return only those elements. So let's check that out. Let's go here, and we're going to go inside of y, and they're going to ask, is y contained inside of the vector 1, 2, 3? And check it out. We only get 1 and 3. So basically, this will allow you to only return certain elements, certain observations that are contained in it. So let's say you're like, I only want this, this, this. It works out perfectly. You can't use the equals equals here. You can't use the equals equals. It doesn't work because this is a much longer explanation. And it returns numeric 0, which means it's a numeric vector of length 0. So it returned a numeric vector that had nothing in it. So many interesting little things here. That's what numeric 0 means. So what did this actually do? This is wrong code right here. Do not code it this way. This is actually like a small but big thing. When you do, and this is a subtle difference, which they do not illustrate here. Let's do this. Wrong for checking if y is contained in. and then correct way. Okay. We even got a warning message, more on that right here. Okay, so the top way right here, with our vector y, let's just look at the vector y so we can see it. The vector y, I can't speak, the vector y is 10, 1, 4, 9, 3. So when it does this check right here, it will say, is 10 equal to 1? False. Is 1 equal to 2? False. Look at the next one. Is 4 equal to 3? False. Is 9 equal to 1? False. Is 3 equal to 2? False. So we should see all falses right here, and it returns false, false, false. It got mad because it's not the same length. We can fix that by adding something into y. We can make y have at the very end of it. Let's put at the end of it 3. So we'll put another 3, and now y has 6 elements in it, and it's going to say, is 1 equal to 10? Is 2 equal, or is 2 equal to 1? Is 3 equal to 4? Is 1 equal to 9? Is 2 equal to 3? Is 3 equal to 3? And it went through it in a matching type way. It went with equal length. And now we won't get the warning message because the vectors have a divisible length. So the warning message displayed because they did not have a divisible length. There was a remainder. And now we will get a true at the end of it because the last one was true. So false, 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 true. And that's using the equals equals, which sees is 1 equal to 10, false. Is 2 equal to 1, false. Is 3 equal to 10, false. Then it restarts this vector. Is 1 equal to 9, false. Is 2 equal to 3, false. Is 3 equal to 3, true. That's how that ran and did the code right there and returned the logical vector right there, checking that. But the subtle change right here is we're seeing is the numbers 10, 1, 4, 9, 3, 3 contained over here. So it's saying, are the elements of y, which it's going to check right here, contained in this? Percent I in percent means contained in. Always read it that way. Are these things contained over here? So look at it. Is 10 contained over here? False. Is 1 contained over here? True. Is 4 contained over here? False. Is 9 contained over here? False. Is 3 contained over here? True. Is 3 contained over here? True. So we should get false, true, false, false, true, true. False, true, false, false, true, true. And the more you can kind of predict what your code will output, the better you get. So practice thinking what the code does. And if you're looking for, is this element existing over here, you want to use percent I in percent. If you're asking, is something equal to something else, you want to use equals equals. So small but subtle difference, which they don't point out on this help sheet, but that's a big thing right there. That's a little more complicated. That's why a lot of people get very confused on the percent I in percent. With named vectors, and we don't have a named vector yet, but let's go ahead and name a vector, and they don't show you how to name a vector either. We have our original vector x with Brian, Brian, Adam, and let's say this is a race. So we're going to say first, second, third. So we're going to take our vector of x, and we're going to go to the names of vector x. Right now, I think they're just named 1, 2, 3, or there aren't. Oh, it's names. Names of vector x. There is no names. It means this does not exist at all. There's not even, it just does not exist. But you know what? We can make it exist by storing into the names of x, which don't currently exist, a vector of first, second, and third. So right here, we've stored into the names of x, and now when we go back and view the names of x, we get names on x. Now when we view the vector x, it's a named vector. These are not elements in the vector x, they're names of the positions of the x vector. So this is a specific named vector now. So x is a named factor vector. A lot going on right there. It's a named factor vector. And so now that it's a named vector, we can go to a named position. We could go here to first, and it will report Brian. We could go here to third, and it will report Adam. And if we were to go to position 1, which we can do, and we've already done, it'll say Brian. We could ask, is position 1 logically equal to the first position? It would say, oops, we have an error, do we? Is position, oh, I did coding brackets. Error number 3. We got this. No more errors allowed. There we go. That is true. And you don't have to call them first, second, third. You could call this position B, position C, position D. And that changes it. And we could ask, is this equal to position B? It says true. And this is going to be true also because that's also Brian. But this is going to be false because that is now the position for Adam right there. So a lot going on right here. We're using a logical check. We're calling positions by numbers. We're calling positions by names. And you can also do this for data frames, which we should see. We should have enough time to get to. But keep asking those questions if you see this. Hopefully this is going to help a lot of people on how to use this cheat sheet right here and understand what's going on. Now we get into some complicated stuff. I've got a video on how to do for loops, and I've got a video on how to do while loops. And we will go over this in both 320 and 474. So here are for loops. And they're doing a pretty simple example with it, but they put a pretty good way of phrasing it. We call this a vector. Variable in a vector. Yeah, it's like sequence is not what I call it. And even doesn't say that instead of R. This was made in 2016, I think I saw, and maybe they've changed the way R calls it. But when you type FOR, so let's put a note right here, learning about for loops. And I do have more videos on this, and I plan to actually probably make a longer video on how to do for loops because I can't do this justice in 3-4 minutes. I'm going to talk about it right here. So with for loops, type FOR, pause. Don't type out anything more. You see it says right there? You hit enter, and it gives you the snip of it. And it says a variable in a vector. Now, there's a lot going on right here. We teach this in our class. When we make a for loop, we need to pick a variable name that will change. Like, it'll change what's in this. So this is just arbitrary. The variable you pick is arbitrary. You can call it whatever you want. You can just hit your keyboard and call it that. And that's going to be harder to deal with. But I usually call it something like I, or I call it like position, but it's arbitrary what you call it. You'll use this later on. Most often you use it, but it's arbitrary. So sometimes I pick something small like I, especially if I'm going to go through and change something in a position, because I can be the ith position. And then we have here the vector, and this is what I will change through. So when the for loop runs, and it's a loop, it'll change what I is every time it runs. So it runs once and I becomes the first thing, and runs second time and R becomes the second thing. And we can view this really easily by saying 1 through 10. So the first time I runs, this will become 1 through 10. The second time it runs, I will become 2. Third time it runs, I will become 3. Now, if I run this, it's not going to do anything. I'll explain why in a moment. Didn't do anything. So why didn't it do anything? This is where the code of the for loop goes. This is kind of the command center, and this is the code of the for loop. So everything you want to happen with the kind of command center you've set up will be done inside of what I call the skeleton. So the skeleton is not going to change. All we're going to do right here is we're going to print I. We need to do print this way. We're going to print the object I. The first time I runs, it'll be 1. The second time I runs, it'll be 2. The third time I runs, it'll be 3. And every time this for loop runs, it's just going to print I. It's always printing I. It's not changing what it's printing. It's printing I. I is changing what it is. So when we run this, we print the numbers 1 through 10. It just does that right here. We could go here and we could use cat paste, one of my favorite ways to print things to the screen. And I think we might need to do, and we could go paste I, and it should print like that. And I'm going to do one last thing right here. This is just a little more advanced. You don't have to know these tricks, but that starts a new line. So we've got right here this. So we've got right here that we are pasting this in, and cat prints it to the screen so it looks like this. It's no longer an object, but that's what cat does. Cat instantly takes whatever you put inside of it and just prints it to the screen like that. So that is how you just print to the screen, and then paste lets you kind of more options on how you want to kind of dynamically use your text. But one last thing right here, let's say we want to put a little more words before this with another argument. This for loop has ran, and then we go right here and say times. I think we can put this right here. Let's try that. Boom, right there. This for loop has ran 1 times, 2 times, 3 times, 10 times. Go right here. Bad idea. Bad idea. Shouldn't do that live. Okay, I think did it do it all? It did. Look how quick that went. That's why computers are awesome. So we just ran the for loop 10,000 times. Did it run all 10,000? Did I type 10,000? Yeah, I did. There's for loop 1,000 times. So it's just going through and running the loop each time, changing what I is. Every time it's doing this, it's just changing I. I could call I just Brian. It doesn't matter what I call it. I just have to make sure here I call it Brian. And then every time it does it, it'll change what Brian is. You notice Brian is now stored in the global environment as 1,000. It's completely arbitrary what I call that variable. The variable is just a placeholder for what will change. And then this right here are the values that it will take on every time the loop runs. And that's about the very shortest way I can explain what a for loop does. There's a lot of cool things we can do with this. That's a little crazier. Like there's a lot more going on right here. And so let's go here to learning about while loops. These are super important, like while loops and for loops. So with a while loop, you're actually going to need a condition inside of it. So go ahead and type while, pause. You got the snippet right there, which is going to give you most of the code kind of formatted for you. So here's your skeleton of the while loop, and here's your control center of the while loop. Now, don't run this on yours unless you want it to crash. I'm not going to run on mine. You could do 2 equals equals to 2, and this is going to be true. Don't do this. This loop will run forever now. I do it in class all the time, but I don't want to do it live during a video and then have my arc crash and everything. We'll not do this live right now. Paste. Oh, I don't want to do it. I want to crash and then spend the next 5 minutes. It'll run in. Everyone's like, do it. Do it. Do it on your own computer. Don't crash mine. Is it doing it? Stop. Oh, he's not pasting it? Print. Stop. 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 That while loop won't end. Didn't crash. Take a deep breath. This is what it did. It just went crazy. It's not going to stop. It filled the whole screen. So that just prints Brian to the screen endlessly. And so, yeah, don't do that. Don't do that. So the while loop takes a condition right here. So it's a lot like the for loop. It runs code and loops over code, and it runs it continuously until the condition is false. So why did my while loop run forever? It's because 2 is always equal to 2. Remember, we did the logical checks earlier. So right here, this is going to take a logical check, and you would never code like that because it's always true. That's a bad idea. You would do something maybe like let's take a vector right here. Let's make our own vector. Let's say x is going to be 1 through 100. Okay. And then you could say while, let's say here, I is less than or equal to 10. And we could just say right here. And this is not a great example. I don't want to do a big example right now, like our casino examples we have in class. You'll see those in class. So if you're wondering, like, how do we use this? We can do casino examples with like betting. We can simulate betting and games and stuff with this. It's really great because if you're simulating money, you might simulate like you'll invest or make a bet if you have, money. As long as you have money, you might make a bet. It's like, how long could you stay at Vegas? If you start with $100 and the odds of this game are this, you could then simulate that. And simulations are great within statistics. We can simulate real world events. So while loops are very, very powerful, especially for simulations. And so while I is less than 10, so let's start our code right here. We're going to store into I, X position, and let's go here, J. It's a bit of a crazy code. And J is like the worst coding ever. Someone's like, Brian, what are you doing? J, we'll go outside the loop here. See, this is why it gets really complicated very quickly. J will start at position 1, and then J will be overwritten as position J plus 1. This is ridiculous code. So some R person's watching this and be like, the worst example ever. So outside of here, I'm starting J at 1, and then we are storing X position J into I, which right now you can highlight this and take a look that this is going to be 1 right there, and that's going to store what I is. So we also need, let's just go right here and store I as 1 to start. And that's what it does start out when the loop starts. And then we'll go right here. We're going to print Brian, and then we're going to restore into we're going to restore into J because it's J becomes, this is a ridiculous code. Oh, cool. Did it do it? It basically printed Brian either 10 or 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, 11 times. That's what I thought. It's because the loop runs when it's less than or equal to 10. And we have here the first time it runs, it's 1, and then it updates it. And I'm just thinking why it ran the extra. It's a conundrum right here, right? And so J, and then because just thinking through it. Let's do this. Let's change this to 3, and I'm gonna think through this. This is Brian's thinking time right here. 1, 2, 3, 4. So the first time the loop runs, I is 1. So it meets the condition here, and it prints Brian. And then I becomes 2. Which this is when students in class are like, no, wait a minute. And then it runs, and it prints. You know what we could do? I'm going to make this super simple. Let's do that. Okay. So the first time it runs, it goes into the loop, and I is 1. And then is it not j is stored as 2? I is going to be the first time it runs. Let's code this out right here. I have broken my brain. And then that stores that into I. And then it's going to print Brian. And then j plus 1 stores into j. Oh, okay. That's we got this. Okay. Because it hasn't updated what I is till here. So we could just go and update I right here. Yeah, that's where we just update I. Let's do that. I knew my code was looking ridiculous. So now it will just print it one time. There we go. That's what I wanted it to do. And so now it'll print it like 4 times if you want. And wait to run the code. That's what it, whoa. While I is less than or equal to 4. Oh, we're not updating it? Did I delete where did I delete that? Oh, there's no J. Well, okay, be careful. We won't worry about this code anymore because I changed what J is and we're not updating things. And so, yeah, we will not worry about it. So it's so easy with code to just make little tiny errors right here and have everything go crazy. Probably the easiest way. Was it now doing it properly? Let's try 4. Oh my gosh. Did I not reset the code? I have broken my code that easily. Oh, it's changing what I was. Okay. I think we're good. Okay, so that's the while loop right there. And wait a minute. I want it to only print 5 times. I'll make sure it does that. Okay, there's 6 times. Probably the easiest way to do this is going to just to start j at 2. There we go. Easiest fixed. So now it works. It prints it exactly the amount of times. This is just kind of fun craziness code right here. Just, you know, crazy code. Just doing fun things. Now let's go right here. If and else. If and else is very, very powerful stuff. How to use if/else. So using if and else, if is going to take a logical and then run the code if it's true. And you can add an else to it if it's not true. And I do have videos going over this too. But if is a function, and if it's true inside of here, it'll run the code inside the code brackets. So this is the way I like to code it next to each other. So we've got if, and it already has a true inside of it. Then it'll run this code inside of here, which is just going to print to the screen Brian. But if it has a false inside of it, is not going to print that code right here. So what you usually see is something like if like max of survey 10 weight. If the max of survey 10 weight, which I believe exists because all the numbers exist in it, we can't find, oh, I forgot to put in weight. If the max of survey 10 weight, and what is that, is greater than or equal to 300, let's do this, let's say large right here. So now we just saw what the maximum is, it's 305, and then let's go ahead and see what happens when we run this. It says large. So why does it say large? It's because the maximum was greater than that. But what if we put 310, or the max is 305? This code right here will not run because it only runs when this evaluates to true. Right now, this evaluates to false. So now it'll do nothing. But what you can do is you can put an else on the end of this. Now, else also takes coding brackets. These are squiggly brackets here. So that's when I talk about like coding brackets that run code inside of them. We saw them up here. These are squiggly brackets. That's a squiggly bracket. That's a squiggly bracket. And also the for loop has the squiggly bracket and the squiggly bracket. So with the else right here, this will say something else if we want. We can do more code inside of it than just this, but this will run right here and it'll say small. That's because else returns only when the if evaluates to false. So since the if evaluates to false, then we're going to return the value inside of else. We're going to run the code, I should say, inside of else. Now you can separate this out a little bit more. You can hit enter here, which they're kind of doing on their code, and you can kind of see it in a more tiered format. This can be easier to look at, and if you're on the code anywhere, you can just be anywhere and it'll run the code. Did I hit a wrong button? Or my code just doesn't want to run? Unexpected. There's always an error. Everyone knows how it goes when you code. There's always an error. So you do it step by step, unexpected. Well, we should be able to go and not. There we go. I'm going to the wrong spots. There we go. I wouldn't make it look like that. You could right there. I went to the wrong spots. Sorry about that. I don't usually break up my code like that, but you can kind of code how you want and make everything look the way you feel is best. So some people will go and they will separate out their code into different formats, and you can always change the indentations on your code, but it'll read through, but it needs this start right here. So I clicked enter in the wrong spot. So this works just fine, and we kind of understand a little bit about the if and the else right there. So functions, this is like this whole thing right here is like the smallest way they could possibly put how to do functions. So what is a function? Well, a lot of what we've been using so far today are functions like max. So if you took the max of this vector right here, this is going to get you the maximum vector, the value in that vector. So this is a function. So using functions right here. So this is the maximum value in that vector. But let's say you wanted, we did this in class, you wanted to do the natural log. The function log takes the natural log of something. I don't think people a lot of times know that. 2.718281828, if you take the natural log of it, is going to be 1, because that's what e is. And what's really confusing that I don't think a lot of people know is that this log right here is in base e. And that's actually what the second argument of this function is take the log of this object. Here's the object we're taking the log of, or the number. And then the second argument of the function is what base are we taking it in. So this will return 1 also. Just like if you do 10 base 10, you will get 1. Or if you do 100 base 10, you will get 2. So what is the log base 10 of 100? It is 2. And it's kind of confusing when you read it because you're taking the log of 100 with the base of 10. Try doing this one. What is the log of 16 with the base of 2? Whoops. Here's the second argument. Whoops, base of 2. And so that is 2, 4, 8, 16. It should be 4. Let's try it. And that's the log of base 2 of 16, or the log of 16 with base 2. But if you wanted to make an ln function, ln does not exist. ln does not exist. There is no function ln. But watch this. We can easily make a function ln exist in the environment by typing function here, fun, fun, and let's do it. F as friends who do stuff together, you know what I'm talking about. And we've got here the function, and this is the name of the function we're creating. So let's go and type in ln. That is the name of the function we are creating right here. And then this is what the function will take. So the function needs to take some sort of object, whatever we put into it, just like we were putting in right here, these objects here. We need to put in the object name, and I'm just going to call it x. Now, it doesn't matter what you call it, but maybe try to call it something that makes sense. You could call this number. That kind of makes sense. And down here, you've got what the function is going to do with this object. So what will this function do? It'll take the log of number. Now you say, well, isn't that going to do log base 10? No. That's going to do log base e, and I've made a function called ln, and you could probably save this into R or whatever you want. So we'd be like, oh, that's my ln function. If you're like, that doesn't exist, we'd be like, I created it. So now when I run this function right here, it uses the ln function, which I'm creating, and it's going to take the log, which is base e, of that number. So let's check right here. Let's go and type ln. And if you notice, whoops, so short, it won't even let me see the help thing for it that we have. It's going to take a number, so 2.71828, 45904, and that is 1, because that is the natural log now. So I created this natural log function by going here and making my own function. I defined the inputs and all this. You could even make a default. We talked about defaults earlier. I could have it default to 100, and we go right here. And we just type ln, and now it can run without anything inside of it. And that is now the natural log of 100. Also, if we view the documentation, it tells us the default for it right there is 100. So that's how I'm able to run this without any code inside of it, because it assumes I want 100 unless I don't put anything. And that's why a lot of the functions you've seen today, like sort, they have defaults in them, which means you don't have to put anything in. It'll work without anything in there. So we've done functions. That's a big talk. Writing and reading data. Cool, this is an easy one. So we've got here, we can read in a data table. And I might not do these ones exactly inside of R. They're pretty much what they are. If you want to read in a data table, a txt file, you just go read.table. And some of the most important things about these writes and reads and saves are this is how you work with data that's not inside of R. I oftentimes use the read.csv, and then you can load in our environments. Let's go through these one by one. Let's say someone gives you a table, a text file, read.table, store into the object, and you can name this. This is any name you want to make it. You can call it Brian. You can call it your name. It doesn't matter. You can call it data for such and such. That's just any name you want to make it. They're calling it DF because that stands for data frame. Doesn't matter what you call it though. If you have something already called DF, you probably won't store as DF because you'll overwrite it in your global environment. We've got right here, read.csv, file.csv. That's just the name and the file extension, like file text is. And then the function is read.csv. And then you're saving it as a data frame again. And the left arrow means like store into that. You can load in our data file, and that's a global environment. So what's that? That's everything up here. This is the brain of R. So if you do that, you'll load in stuff into the brain, like functions, like not libraries really. You'll load in functions, objects, values, data frames, all that good stuff, and that'll be done with the load r.data file. You can also save your R environment. So if you have an R environment that you currently want to use, you can save it. That can also be done under here, under these icons, where either you save it, that's the save environment, which are the function we just looked at, and here's the load environment right there. You can load in a workspace or save a workspace, and that's the kind of r.data files right there. So there's buttons already inside of R for this. You can take the files that you've been working with. If you've worked with a data file and you want to save it to your computer, you can do write.csv. You need to call the object. Here's the object you're working with, the data frame, and you need to name the file name. Now this is going to be the function you use right here, and this is what you want to save, and this is what you want it to be called. Same thing with the write.table. Here is how you, the function you call to write a table, pretty obvious right there, and this is the object you want to save, like the table you want to save, and this is the name you want it to be saved as on your computer. So you'll put in the name you want. Make sure you see the color distinction here, because when you put in these things, they should change colors just so we can see. Let's hop over to R and do one of these as an example. Write.csv. So this is going to write it to my computer. I'm going to call survey 10. And when I call survey 10, I need to put a comma for the next argument. And you see the next thing up there is file. X is the object I'm saving. File is the name. I'm just going to call this random survey 10. I'm going to call it CSV. Now that wrote it to my computer right there. So it's saved on my computer in my working directory in my downloads. So it'll have the name. This is the object you're saving, which is there in my global environment. And this is the name of the thing you're going to call it on your computer. Okay, what else we got? Conditions. Here's our logicals. Yay, we got to some logicals. Equals equals is going to be... wrong button. Let's do logicals right here. Logicals in R. Okay. So when you do logicals, and I do have another video on this, going through all of them, you have equals equals. So equals equals tells you if something is logically equal to something else. So it says is 2 logically equal to 2. And let's see here. Let's do is 2 logically equal to 2, comma 4 or 5. And that's going to return true, false. So is 2 equal to 2, true. Is 2 equal to 5, false. You can also do it with longer vectors here, and we'll do each one pairwise. So this will return true, true, and this will return false, true. So kind of understanding how to work with it a little bit, it's just checking to see if they're equal, but they show you some simpler formats right here, but it can take vectors and it can take values and it can take all different types of things for logical checks. We have not equals. So this is just, it just flips it. All it's going to do is take trues and falses and it flips it. So if you notice this was false, true. If we do not equals, it'll be true, false. It just flips it. And I really like that exclamation point because you can do not true and that'll be false. You could take a vector, like if you already have, and this is just how to use the exclamation a little bit. Let's just call here a logical vector. And I'm just creating that object. I can call whatever I want. I can call it logical vector. I'm just going to create it. And I'm going to create one that's true. Notice how it changes color. False and true, false, and 1, 0. True is the same as capital T, is the same as 1. False is the same as capital F, is the same as 0. Just kind of a thing to point out right there that R sees all those objects the same. And so this is a logical vector right here. And let's go ahead and take this and do an exclamation on it. Remember, it's true, false, true, false, true, false. And let's take an exclamation. And let's repeat it again. True, false, true, false, true, false. False, true, false, true, false, true. Just kind of showing there that I flipped the logical vector. It takes trues and falses and flips it because I put an exclamation. So you have equals equals is logical equals, and not equals is exclamation equals. And you can do as an exclamation on a logical to just flip it. And so we're just showing here that all of these are treated the same way, and the exclamation flips the logical vector. Whoa. I was like, when did I run that code? So next we have greater than and less than. Here we are with greater than and less than, greater than or equal to, and less than or equal to. Pretty obvious stuff right here. I mean, I can show you right here is 5 less than 2, 2 less than 5, 2 greater than 5. But these are classic kind of 2 greater than 5 false, 2 greater than or equal to 2 true, 3 less than or equal to 3 true, is 3 less than 5 true. I don't know why I paused on that one, but just kind of, using it. Make sure you can't do, I think a confusing thing people do is they do something like, see, I have to stop, equal to or greater than. That should break it, and it should say, nope, don't know how to do that. I mean, we know how to do that, but R does not. We're smarter than R here. So let's put a big thing like does not work. You have to do greater than or equal to, less than or equal to. It's kind of the way we say it. So remember to do like greater than or equal to, less than or equal to. That's kind of a common mistake up there that I've seen before. Okay, we've got is.na and is.null. I've never used is.null before today. So these are logical checks. I've used is.na, use that a lot. Is.na checks to see if something is missing. Na is missingness. Please note that it's a lowercase na here and it's a lowercase null down there, but the objects themselves have uppercase letters. So these na and null objects, if you type them, if you type na, it's missingness. That's nothing. It's telling you that there's a box that has nothing in it. The element position 1 has nothing in it. And to better explain this, let's look at a vector here of 1, 2, na, 4, 5. And if you notice position 3, which I kind of just numbered things off, position 3 is missing. Now position 3 is not the word na, you have to watch out. This is now green because it's the word na, and that actually forces the whole vector to be a character vector. And notice everything's in quotes now because one of those things is a character, so the whole vector becomes a character vector. So watch out, there's a common mistake. You do not want this right here. And so if I were to save this, let's save this as vector z, and then if I do is.na on vector z, it'll tell me if things are missing, and we should get true, true, false, true, true. Ooh. False, false, true, false, false, because the only thing that is missing is the third element. And if you want to see if something is not missing, that's what I was kind of thinking in my head, the next example, you can put an exclamation, and this is not missing. So this is going to return true, true, false, true, true, and we have this right here. And this is where we go a tiny bit more advanced. We go back to what we learned earlier about vector positions, and we can return the elements that are not missing. And there's the elements that are not missing. So I took my logical vector and put it back inside of the vector. And we did this earlier on. Go back in the video to where we talked about vector positions. But I used my logical vector to return the things in those positions that are true. So you can get all the elements of a vector that exist with this is.na. I haven't used is.null much ever or before today. Represents the null object. And so if something is null, like is null null? Cool. So I don't have any great examples with that right now, but if you had an object that is null, which probably if I say like, let's say here, MLA, is Emily null? Because I can't even find that. But see, I don't have any null objects. I don't have any null objects in the environment. So it's family member name, Darren. Darren is not null here. Darren does not exist in the environment. So if you were to have an object that was a null object in the environment, then it would return back. So I don't really use is.null much. Haven't had much use of it in what I do, but it exists. It's a thing. So cool. Sorry, I got very little explanation on that. We got a little bit more time here, so let's see what else we can do. Let's go over here to the left. Let's see where we get to in this. I'm trying to think when my next class starts. Math functions, but before that, types. Types of variables. So when it comes to different types of variables here, we have logical, numeric, character, and factor. We've seen a lot of this today right here. Note how logicals are trues and falses. Booleans right there. It can be t, it can be f, it can be 0, it can be 1. We'll bring it up here a little higher. And so as.logical. Now there's something they don't show right here. There's the is. So let's do types of data in R. So if you have something like is logical, this will check to see if something is logical, and that is a logical. But this right here is not a logical. Notice how it's telling me that the word true is not a logical, like the word Brian is not a logical object. So this is a logical check to see if something is a logical object. Is it logical? But is Brian a character? That is true. Brian is a character string. Is Brian numeric? Is Brian null? Never used that one. Is Brian numeric? Brian is not numeric. Is Brian an integer value? Brian is not integer value. Is Brian infinite? I don't even know what that one does. Is Brian finite? Is Brian infinite? Brian is not infinite. Oh no! Is Brian finite? I'm missing one right here. Brian is not finite. Brian is not infinite. I'm probably just not that type of object. So these are checks right here. One of the biggest things you're noticing right now is there's the is, and that lets you check if something is a certain type of object. So you can take an object inside of here and say, is this? And you can use the as, and let's do as, and let's go to numeric, and let's take the vector right here, and this will make this a numeric vector. You can also go as dot character, and notice now this becomes a character vector. You can go as dot factor, and this becomes a factor vector. Notice this is I think one of the best things to learn right here is there's the is and the as. Is does logical checks. It checks to see if something is this. As does turning something into something. It says save this as this. We could then store this vector right here and say factor or numeric factor. And we can store it right here, and we've stored a numeric kind of factor type thing. There is some interesting caveats with this that we go over, especially in 474 and a little bit in 320. Be very careful switching between different things because the way it converts it can be a little bit confusing. So watch out when you're converting stuff. I think I can show that right here. Let's do this. Let's do the confusing example between converting stuff that runs into problems. So if you have a vector, let's go here and say numbers. We're just going to store a number vector. We know how to make a vector with the C, the concatenate. We're going to glue some objects together right here. And let's try this. There we go. We got some numbers. Now, when we take numbers and we turn them into, I'm trying to think which way we want to change this right here. I'm thinking of where the example goes wrong. I always know when I do it by accident. And then I'm always like, oh no. So let's go right here and let's go as dot factor. Yeah, this is it. Okay. This is going to do it. Okay. So now we've turned it into a factor. Cool. And now we're going to go here and we're going to go numbers. And this is like how many Ferraris people own. So it's like, whoa, someone owns 100 Ferraris. So now we're saving that and we've got this right here. But now we messed up our data. Let's bring it back. Let's go back. That's where the error is going to occur. We're going to take this and we're just going to take it right here and we're going to go back to as.numeric. Then we're going to take a look at our vector right here, and what do we see? It's completely different. So this is kind of the big mistake people make, is that when you go from a factor to a numeric, it puts the factors in numeric order. So let's put this right here. When going from factor to numeric, it puts the factors, I will do this underline, to numeric. It puts the factors in numeric order. It's a common mistake right there, and if you change your data, it causes problems. So watch out, very common mistake. So what do we need to do? If we want to actually get this fixed up, let's copy our code right here and do it the right way. You can't, if you have numbers that were saved as factors, you can't just turn them to numeric. So the step you have to do between this, the step you have to do is you have to take, and we'll just copy our line of code right here. If you have numbers that have been saved as factors, you have to do as.character. So now we're going to take our original things here. We're going to save them as factors, which we're just showing an example. You would never take your numbers and save them as factors. We're going to take these numbers right here, which are factors, and then we're going to turn them into characters, which means they're words, and then we're going to turn those words into numbers. And now we've preserved the original data values, where before we we alphabetized or ordered the numbers. It orders them by numeric/alphabetic order. So that would be a big problem right there if you destroy your data. And that's how we can use the as right there. It's changing the variable type, the class of it right there. We talked about that earlier. So the as changes the class, it saves it as a class, and then the is checks what the class is. It'll do a logical check to see if it is this. Set the is and the as right there, all this good stuff, and they've got multiple versions. You could do is logical, check something is logical. You can do as logical to save something as logical. Math functions, tons of math functions right here, so many. Log, exp, and max. So exp is actually e, it's Euler's number, Euler, hopefully I'm pronouncing the gentleman's name correctly. So log, once again, is going to do log base e, but the second argument right there is the base you want it of, so you could do log of 10 base 2. And think about this. That means if you raise 10, let's do this. Let's do a comment. This is equal to, or this is because equal to this, because 10 raised to this equals base 2. So 10, my brain's just 2. There we go. That's where I got it wrong. Equals this. There we go. 2 raised to that power equals this. Logs are lots of fun. I don't have to deal with logs that much, but 2 raised to this is that right there. And there we go. exp right here is going to be Euler's number. So if you do exp1, you will get 2.7182818284594523, all that good fun stuff right there. And this is just returns e to the power we input. And for this example, it was 1. So that's going to return e to that power right there. So that's what that does. And then next we see max and min, just returns the largest and the smallest element. We already have a vector up top. You can see it right there. It's z. So we can take the max of z, and that's going to return 5. Ah, but they don't tell you this in the thing. There's a second argument right here if there's NAs, and you have to do na.remove equals true because there was an NA. And now we get 5. I think y does not have NAs, so we are able to do the max of y. So since z had NAs, you have to do na remove equals true. And that's why I like going over these kind of help sheets right here, because they don't tell you everything. And I'm not telling you everything. Put comments below. Be like, hey, Brian, you messed this up. Well, be nice. Be like, you could do this. And I'm like, oh, that's interesting. We can do a lot. And so min works the same way. Min will work for the min of y, because that does not have NAs, but min also will have the problem with z. You see it says na remove is currently false as default. And we need to put a true right there to change it to actually get the min of z, which is also 1. We've got right here round, just round certain things to a certain amount of digits, and significant digits, which gives us the significant digits. So we can take round, take an object like this right here, and round it to 0 digits. This should return 212. There we go. We can round it to 1. If you notice, it rounds the decimals after that. So it's how many decimals do you want rounded afterwards. So if you had something like this right here, that would round up. And if you had something like this right here, this would round down. Classic stuff. Do they mention floor and ceiling? They do not mention floor and ceiling. So if you have floor, which I'll leave this on the screen, and floor only takes 1 argument from what I remember about it. But floor is a good way. You have the floor right here, which will bring it down to the next lowest integer below it. So even if this was something that would round up and you use the floor on it, it will round it down. And you have ceiling, and ceiling will take it and round it up no matter what. It doesn't, if it's very like, let's go right here and go this. If you do the ceiling on this, it will round up. And if you do the floor on this, it will round down. And it goes to the nearest highest integer. Floor goes down and ceiling goes up. So that's why they call it floor and ceiling. It's amazing naming conventions right here. Significant digits, round to n significant figures. I use this one every so often. Significant digits right here. So let's go ahead. Number of digits you want it rounded to. So you could have something here like this, and you could say 4 significant digits, and there we go right there. The 4 significant digits, the 8 significant digits. And I've never liked the way that formats. I've never liked it works on a weird way. Is it because I've had my qualms with significant digits. I remember a student and I were going over it and we were like, just what's going on? We've got here correlation, which should be more in the stats portion of this. So correlation right here is going to do the correlation between 2 vectors. So you actually need to input an x and a y vector right here. So you can name your x and y beforehand. So let's go here and get an x and y vector named. So we're going to do x save into, there's our x vector, and y save into, and let's do a negative correlation. So we're going to do -5. Oh, it doesn't need to be negative. We can just go 8, 5, 3, 2, and we'll make it not perfect. There we go. So generally these numbers go up and these numbers go down as these numbers go up. So we should see a negative correlation between these two, and there we go. Really quickly, you could plot this out nice and easily just with the plot, and you can see, whoops, figure's too large. If you get that error, you increase your window size, and there you go. If you notice, it's a generally good negative correlation, kind of decently strong with -0.75. So that is how you do a very quick plot. There's a ggplot thing at the end of this help sheet, and I think ggplot's one of the best things we have. So check out ggplot. And let's see right here. Round to that many digits. Correlation, sum, gives you the sum of vector, mean, median, quantile. So with this right here, we can take the sum of that x vector we just created. Boom, there's the sum of the vector. We can get the mean of it. And please remember, I think I overwrote my vectors, but if one of your vectors has NAs, these also, I believe, need to use the NA.remove. So if your vector has NAs, you have to do NA remove equals true. It's a common thing because they won't take the values if there's an NA. Very, very common error we see that students and other people are like, wait, this won't actually get the mean, this doesn't get the sum, what's going on? It's because there's an NA. So if you get an NA as the value, it's probably because the vector itself has an NA in it, and that's the problem with that right there. And we see quantile, we have median, we didn't do median yet. Median, since we do have an NA, and it looks like it's going to be 3. There is no 3, but the median of this vector is 3 because there's 4 numbers, and if you average together 2 and 4, you get 3. So the median's 3. Quantiles gets you the percentiles in a vector, and so if we get the quantile of x and we go to the 99th quantile, oh, what did I do here? Quantiles, what happened? Oh, NA, oh, it has NA remove. Oh, we said missing values, NA is not allowed. Can you do NA remove this one? There we go. I don't really deal with, I mean, I deal with NAs sometimes, but I don't always use the quantiles, and you have to do NA remove. A lot of times with quantiles, I'll do another example right here. I'll use it for things like weight. We've already got our survey 10 loaded up. I did this way earlier. So if you're wondering how do I have this, I loaded it way earlier. If I want the tallest people in the class, I can go here and I can get the 99th percentile of heights, and I can get the first percentile. So these would be the shorter individuals. So the shorter individuals are around 56 inches tall, the lowest 1 percentile, the lowest 1% of heights, and the highest 1%, which is the 99th percentile, are 6'4" and taller. So this lets you get percentiles. You can also get the median with this. You can also get the IQR with this, but you can also get the IQR even easier by just taking this right here and running IQR. So that'll get you the IQR right there, which is 7. So with this, we've got rank, the rank of the elements. So rank just tells you, if we take a object like our first one, it's just going to tell you the order of the objects, if it's the first, the second, the third, in terms of largest to smallest. So there's the rank of the objects inside of there, but it works better if you use something like weights. And just so you can see, these are all the weights of the individuals. And so there's everybody's weights, and here's everybody's ranks. So this is where they would be in terms of, you see some ties right there, but this is their rank of weights. Just so we can see a smaller example here, let's take X and go here with 100, 2, and 1, and 8. So when we go rank of X, we should get 4, 2, 1, 3. Did I reverse it? 4, 2, 1, 3. Good. 4, 2, 1, 3, because it's giving us the rank. The highest rank is going to be the largest, and the smallest rank is going to be the smallest. So you can see 4 because that's the highest, 2 because that's the second smallest, 1 because that is the smallest, and 3. So it doesn't matter if I change this to 99, we'll still get 3 because it's the second largest in the for the ranks. So that's how rank works right there. The variance, I don't like variance. So this just gets to the variance. Variance is a measure of spread of data. It's like how spread out the data is. Variance is in squared units. Standard deviation is in non-squared units. So you could take and square your standard deviation. If R carries enough significant digits, you'll see that that's equal to the variance. So standard deviation squared is variance. Why do we oftentimes use standard deviation instead of variance? It's because standard deviation is in non-squared units. So variance is in squared units. Like you're talking about squared height. It doesn't make much sense to me. And the normal curve I like to use just with standard deviations. So that's personal preference right there. Some people use variance. I use standard deviation. Variance is just standard deviation squared. And we showed this mathematically here by, we could literally just go, here's our variance, and here's our standard deviation squared. And as long as R carries enough significant digits, they are equal to each other. So there you go, logical check. Is variance equal to standard deviation squared? Yes, it is. So we're using some of our previous knowledge here to kind of help us out. And these are both just measures of the spread of data. How are we doing on time? I think we're doing pretty good right here. I'm gonna do one thing. I'm gonna be right back if you're watching this. I'm gonna check my schedule, make sure we got more than enough time to do this. We are back. I've got more than enough time. I've got another almost 2 hours. So we can get through this whole thing, and I'm hoping this helps people. I'm going to put some markers in here, and hopefully people can use this as a resource to understand how to do different things. So we've got here just saving something. They're going to tell us this now. We've already done it a bunch of times. But if you're watching and you skipped this part, this is how you save something into an object. So I like to use the left arrow, but let's talk a little bit more about this to see what's going on. So let's go here and go variable assignment, and we are going to take and call the object A and store it into it apple. So the word apple is going to be stored into the object A, and there you see it appear in the global environment. So if I were to take a vector now and put inside of it A, you would get apple, 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 because the vector I'm creating has the object A inside of it, and the object A is apple all the way back there. And there are some other ways to store stuff. I'm not big fans of them. You can use equals. I don't like that. If you're wondering, you can put orange here. So that's why did we overwrite what we had? There we go. And so you can also, I would not suggest this way. I've used it like rarely when I just want to put something on the end of a code, but you could go and do, let's say, lettuce. I guess I spell lettuce. And store into this right here, C. So the way the arrow points is the way it's storing. Not advised for storing. We don't do this here. We don't do this here. I wouldn't do this. Line 175 it's personal preference. I don't like doing that way of storing. But if you look now, we're going to make dinner here, and let's just store the object dinner. And the object dinner is going to be a vector of this right here. There's our dinner, and that's dinner. And let's take a look at dinner. What is dinner? Here is dinner. There's dinner, a bunch of apples, oranges, apples, and lettuce. And so we're creating this dinner object and storing it. And we could have just as easily have changed it to the equals. I like using the arrows because we use them when we create objects, and inside of defaults for functions, we'll use equals. So I use equals for functions if you're wondering why, and then for storing things, I use the left arrow. So I left arrow to store into an object, and a lot of the defaults for R generally do that too. If you look, you'll see, especially for the function one I think I was thinking about, it left arrows. So you're almost forced to use left arrow sometimes, even though you could probably, I'm 99% sure that would work. I've never run it, but yeah, let's do this here. Real quick review. Let's just change this, and let's just call this add two things. And we'll just call this here x comma y. This is a review of function real briefly. And then we'll just go return x plus y. This will add two things, and we've created our own function. And so add 2 and 6, and there it works. So that confirms it works, but I don't like using the equals. I like using the left arrow. That was a super quick example. We already went over functions earlier. Check it out. There's a lot to functions. That's a whole lesson. So you've got your global environment right here. This is where everything's getting stored. So here's your global environment. Everything I've been working on is stored here, and we're about to lose it all. Maybe you want to see what's in your global environment. Hey, that's what's in my global environment. You could also look at what is the 8th thing in my global environment. It's the iris data set. We could. What is everything but the 8th thing in my global environment? There we go. What are the first 1 through 5 things in my global environment? What is everything but 1 through 5 in my global environment. So we got to do this right here. So this is kind of a review of earlier, but this is the function to see what is in your global environment. The ls parentheses function tells you what is in your global environment. So all it does is look up here and tell you these things. It can be kind of useful. I don't use it that much. But then we have how to remove things. I use this one quite often. So if you want to remove that iris data set, you go here and we remove it. And if you notice now, I think it was iris was the 5th thing or was the 8th thing. So it won't be the 8th thing anymore. We go here to ls and we look at everything in there. Iris is no longer there. And we go to the 8th thing and iris is not the 8th thing. It's the letter J. We could remove J if we want. And now we've removed J. J does not exist as the 8th thing in the global environment. RM stands for remove, and it removes things from the global environment. But if we want to remove everything, we're going to go to remove the list of everything in the global environment. So we go to remove the list, more on lists in a moment, of everything in the global environment. And we've done it. We've emptied our global environment. Now, I wouldn't code it that way. I would just go here and clear the global environment. You can always clear what you have with these dustpans. This one's a little harder to see, but you can remove what you currently have. It's much easier than typing this out, but maybe you're using an RMD and you have to remove the global environment midway through. I just don't see much purpose for this code right here, but that's what that does. Removes the list of everything in the global environment. So we've got that right there, and I think that's the bottom of that. We're almost done. We got so much done right here. Let's go right here to matrices. What we got going on with matrices? There we go. My head's not blocking it now. Okay, matrices have rows and columns. You're like, well, no, duh. Be nice to me. They have rows and columns. So with rows and columns, you actually have 2 positions, and that's what you're seeing right here. You're seeing the 2 positions for rows, and if you're remembering, it's I want to rock. So why do I say I want to rock? Because it's rows and then columns. I used to teach a class that we covered this, and people would always get it confused. Is it columns, rows, or rows, columns? So remember, I want to rock, rows and columns. So right here, we can take and create our own matrix. I don't do this that often. This will take the vector and make a certain amount of rows or columns in it. I think the quickest way to make a blank matrix, if you go right here, is if you go to matrix and you call NA and you make 5, 5, we should get a matrix of 5 by 5. And if we want a matrix, it should, I think it goes long ways. I don't make that many matrices. There it goes, puts it in vector format, and we filled in some values. I don't want to fill out a whole matrix, but we should be able to do the following. 8, 4, 1, 3. So it should go 8, 4, 1, 3. So it'll be a 2 by 2. And if you notice my formats of the code right here, the first argument is the values you want inside the matrix, and then the second argument are the elements, the rows and the columns. So we have the values we want and the rows and the columns we want, and this right here, let's say working with matrices, C's or data frames, because I'm going to mention data frames here too. So we could store this into object M because it's a matrix, and now we have that matrix stored. A lot of things you can do mathematically on this, and this is in the bottom corner. You can take the determinant of this matrix. Let's see here, 24, 4, it should be 20. Do I still know how to do basic matrix algebra? 20. We took the determinant. You can transpose this matrix. I really haven't used this. Is it transpose? I saw it there. What is the code? Transpose it. oh, it's just T. That's easy enough. So if you're in matrix algebra or things like that, you can do your matrix algebra here. It'll solve it for you. And you can do matrix multiplication. You can solve a matrix right here. I haven't solved the matrix in forever, and we won't do that in our class. Find x, so m times, you can solve 2 matrices. Oh, find x, so equals this. That seems pretty valuable. Let's check it out. Okay, so it's going to solve for us what is x. Like, we know the product of 2 matrices is this. We can multiply 2 matrices. So let's go here, and we are going to simply hop into here. We need another matrix. I mean, we're going to go through everything on this sheet. Someone was like, no, I need this for my class. I'm like, okay, I got it. So we're going to change this right here to 2 and 9 and 1. Cool. We have 2 matrices now, and they're the same size. This is not really a statistics related thing, but it's on the sheet, so let's cover it. We can take and multiply these 2 matrices, which I have never ran this function before today. I didn't even notice that this was on here. So this is m %*%, and you notice it changed colors. Does everyone see that? Just a slight, you have to look very carefully to watch the change of colors. So watch it as it just barely goes lighter gray. And then this should get us the product of the two matrices right there. So it's the product of the two matrices. So that's how you multiply two matrices, but you can use solve. And so this is going to take two matrices right here. It's going to take M, and it's going to basically solve for, if you were to multiply M by X, it would get you N. So if you have some unknown matrix, like if we were to take M and multiply it by X, we would get the product N. So what is X? And the product X would be that right there. So pretty neat, solving for use in matrix math. It's great to know how to do mathematics. It's great to know how to do determinants and all that stuff. But especially when we do coding, like we might say, okay, we need to solve for the product of these two matrices. We're not going to do it by hand, especially because we're going to run like the product like 1,000 times or something in the background. So we might be doing like a genetic algorithm or something like that. So we don't do this by hand. We just realize what we have to do. It's like, okay, we need the product of these two matrices. And then we hopefully understand the theory of why we need the product. That's also important too for our classes. So we use code to help us solve things. We don't have to worry about solving the mathematics of it. Doesn't hurt to know how to do the mathematics either, though, like that determinant. Yay, Brian still knows how to do a determinant. So matrices and data frames, so I'm going to mention data frames here briefly, are two-dimensional objects. So you have your rows and your columns, and they're showing you what it will return. This is a really great visualization right there of what it will return. So you can look at my matrix M right here. If you go to my matrix M, it's the 8413. And if I go and say return to me just the first row, it'll return 81. If I say return to me this, it'll return to me everything. And if I say to return to me this, it'll do the first column. And so it's going to return 1, 3. Now I want to point to something bigger now. Let's go to the iris data frame. So here's the iris data frame, which is still loaded inside of R. It's kind of always there. If you want it to reappear as this, we could just go to data, and here's the iris data frame now inside of there. But it's funny, iris always exists, kind of like empty cars always exist inside of R. That's a bunch of cars data frame right there. So those always exist. You don't even need packages for them. So with this right here, let's go ahead and look at the iris data frame and do the same sort of thing where we take just the first row. So this right here, if you think about it, would just be this first row of data. And we're just going to see the first row of data in the iris data frame. What about if we do the first column of data in the iris data frame? Now we get the first column. And it doesn't look like a column because it's wrapping it around the screen. So right here is the first column in the iris data frame. And that's what we got going on right there. We can do the same sort of manipulation where we take everything but the first column right there. We could take only certain columns. But everything we learned earlier about taking certain portions of data, we can do right here. We could take rows 1 through 5 and columns 2 and 4. So when you read this, this is the row space, and let's put some notes on this. The row space is going to be right here. This is the row space, and this is the column space. So there's your row space, and there's your column space, and that's how we would use this. Okay, just understanding what's going on and the same sort of manipulations from earlier. And it's a lot like a matrix. Lists. I don't use lists that much either, but they're pretty good, especially when I use them when I get my data returned. So with lists create things like in folders. So when you think of lists, so what are lists? Lists basically put things into folders, and we can do this right here where we can create a list. Let's call this list1. And we call the list function. We want to go to there, the list function. And we're going to create a list that has the iris data frame in it. It's also going to have the word apple, and it's going to have a vector of, let's go here. It's going to have the vector of, and I think we can call the vector x. Let's call the vector x equals to 1, 2, 3, 4, 5. And it created it. There's our list, and we can view it over here. There's the iris data frame, there's the apple, and there is the x vector we created inside of it. And now this is where things get a little bit confusing because remember the square brackets are positions. So they have some really good notes on this where they tell you the difference between the double bracket and the single bracket. So the double bracket is going to return the second or third element, whatever we want. And let's see this right here. If we go to our list1, which is the name of our list in the global environment, and we return the second object with double brackets, we will get just apple. But the difference here is if we use a single bracket, it'll create a new list of just that element. So now this is a list, it returns a list. So notice the key difference here. that this right here returns the element from a list. So if I want to return the iris data frame, I'd return this. And then if I run this, it returns a list with the iris data frame in it. So you might not see it, but all the way up here, it's going to have the list notation on it right there. So this is a new list where the first element of that list is this. So the key difference right here is returns. Got to make sure I do this right. Let me double check because I don't want to say it incorrectly. It's a subtle difference. That returns the element, returns only elements. And this right here returns lists. So the return on this is a list. The return on this is your elements. So if I go here and do this, I should get, there we go here, out of bounds. Yes, perfect. I get out of bounds because I'm saying go to element 2 and then the third thing in element 2. Now I could go and I should be able to get apple right here, apple. That's because at element 2 in this list, there's one position. But how about, I might go really complicated here. So if I'm returning elements, I can go to element 3, which is here, and I could return the third element of element 3, which is 3, and there it is. That's where I'm going right there. What if I go to here? There's 5. Here's where I'm taking a deep breath. Let's go to the first thing, which is I'm going right here. I'm going and returning elements, and I'm going to go to the first row, and I'm going to return the 5th column. And it says 5 right there. Is it 5? Is it 5? I thought it'd be something different. 4.6. Oh, wow. There it is right there. And rows and columns. Oh, does it do columns first then? I've lost myself. I usually don't go this deep into this right here, but I want to see what's going on here too. Let's go to iris and see what's going on. Rows and columns. We're investigating. So if we put in, because we're in the iris data frame right now, there's that. Let's go over by one right here. There's that. So this is that's the column. And so if we go over to 1, 2, 3, 4, 5, we should get that. And that's where I got confused. There's 1.4. It's returning what this is, I think. No, it doesn't make sense. Oh, no, that is the 5th element. Did we run that? I think it's returning what this is in the... so that's returning, I believe, what that is in the factor position. I think the iris data frame goes, the names of the flowers are in order. Let me just take a quick. If you look at this right here, the names of the flowers change as you go down. And so we should only get flower names 1 through 3. And if I go to flower, this would be, no, we need to stay there. That's 5. And this is 150. It should say 3. Yep. And if I go to 75, it should say 2. Yeah. There's only 3 names of flowers. I don't like that it's doing that. It's forcing it to be numeric. That's interesting. So not a good way of doing it right here. But that's forcing it to be numeric. And we'd have to do more complicated work to get this to work. But this is going inside of right here. It'll give me a script out of bounds if I do this because there's not 3 dimensions to this. I'm going to list element 1, and then this is actually the columns, and this is the rows. I probably wouldn't do this. I would go here, and I'd get the data frame like this, and then I would we should be able to go here and do this. There we go. So this is a much better way of doing this right here. Hopefully you see the difference right here. This is going to list object 1 and returning it. And since this is now literally just the iris data frame, I'm just going to the iris data frame and doing this. So the codes here are the same because it's returning this. Now, if you go and do list 1 of here and you do this, you will get another list as a return. So be careful. I do not believe this will work because now, yeah, it's script out of bounds. Because now this is a list and you're going inside, you're asking for things in the list. Little confusing. Hopefully I didn't just massively confuse everybody. But if you do the double brackets, you return just that object. If you do the single brackets, you return a list. So once again, this right here, let's just see the simple example. We return just the element apple, We return just the element apple. And this right here, we return the list, a new list with apple in it. So you could return the list without iris data frame by doing the following, and this would return a list without the iris data frame. So you could call this list 2 and that. And so that's just kind of how to manipulate lists, a little bit right there. And last but not least, because it is on the sheet, so I want to mention everything on there. I got caps lock on. If you go here, we named this X, so we should be able to get object X, and we want to take that object and just return that object. And here is object X, and if you change it to the single brackets, you will get a new list with just object X. That's a new list of just object X. That's a list return with the object X in the list. A lot going on right there. And there might be another question. Let's see. Let's hear it here. General question. Oh yeah. If you have a question, I see the question on here. If you have a question, feel free to ask. I'll answer any and all questions I see on our server. So feel free to ask or leave a question and I'll answer it. I've been going over the help sheet today to just kind of help everyone out. And I'm going to mark this video up. And oh, it has data frames on here. I think we can get this done. I'm going to go eat some lunch here in a moment. But feel free to post a question. I saw that someone was asking how to ask questions. So we're using this right here. Feel free to ask a question and I'll go over it. Be like, hey, I was wondering about this, and I'll work it and we'll do the questions. They have how to make data frames. So how do we make data frames? Yes, there's a, let me go to that reply. So working with data frames. Let's go look at that reply right here. Oh, here we go. Did I have a chat? Yep. I think we might have to do a to be continued. So be right there because I'm supposed to be on Discord. And let me do that. We got to the data frames today. We will continue this tomorrow. And because there's still a good bit to go through, and we're going through this nice and slowly, step by step. So that's got it for today's stream. Check this out, and we'll go through the remaining portions of this. We've done a lot of it, but there's still just a little bit to cover, especially with strings and data frames and subsetting. We pretty much did the data frames one, and strings is a little bit, and there's factors, how to turn them into that, and statistics, ooh, that's a good one, and distributions, and then just plotting. But that's got it for today. Feel free to drop your questions in the chats that we have. We might open chat back up. We'll figure out what's going on, but I'll see people in class here soon. Bye, everybody. Bye.